All right, let's see. What do we need to do to... We got background. We got soundboard. We got mic. I think that's all we need. I think we're ready to go. So, here we go. All right. Well, hello, and welcome back. So I'm still on the BLS train. Ryan informed me that I was looking at the wrong draft. Thankfully, there's not much difference. There's a different... there's a guarantee that the private key can't be 0 bytes. Okay. And then I think for the random generation, it has to have a salt. I guess that's so that even if the input is 0 bytes, that the output will not be 0 bytes. And then it looks like there's just some more comments and then informative references. So I don't think there are any material differences. Oh, and it looks like they fixed a typo. Okay, yeah, the private key needs to be at least... Yeah, so actually, I don't think that they... Between 3 and 4... I don't think that they even changed the thing about the salt. Let's see. Oh, this one has salt. Procedure, while it's 0, salt is equal to salt, extracted salt, some other stuff. Okay, PRK. So they just moved this whole bit into a loop. And then... All right, so I guess there's like a 1 in a, quadrillion chance that a hash could produce an all 0 byte value, and this just formally says no to that. But in reality, it's like the number of stars in the known universe, the number of atoms in the stars of the known universe, like 1 in 1 of those of a chance of it being 0, but it makes sense. Just can't be 0. Sure. All right. And then other than that, I don't. There was additional comments added. Okay, and this makes sense too. If it's either invalid or the identity element. So I don't know exactly what that means, but I guess, a point where f of x returns x, then don't do that. So, yeah, I don't think that there were any material changes. I think that there was just a clarification on that 0 byte. So they're not going to be a difference. Now, if we go to draft 5, so let's look at the difference between 5 and 4. There is a potentially material change to the fast verify function. So let me go forward to this. Okay, it also says that it is 126 bits of security, so that may be a typo change. And then a correction in a word, a new line. The keygen now takes the seed and the salt. Okay. So yeah, this is essentially the same. some section number changes. Okay, and this part is just adding more words. Did this actually change? Because it looks like this diff is just a bad diff. Because they added a paragraph, and for whatever reason, it's detecting it as a change rather than an addition, apparently because the word result is in the middle of the paragraph, and so then this whole thing. And then because the word message is here, and the word message is also there, then it's just keying off of the word result and the key message, and it looks like there's actually no change. Again, this looks like a comment and a clarification on, you know, it's greater than 1, but the procedure is the same. So the salt value for the keygen is going to begin with the keygen salt. So, and then a bunch of numbers get changed, and then the revision of the source material is just getting changed. Instead of being in master, it's referring it to it's like permalinks. Okay, so yeah, even with this, it doesn't look like the only material change is the recommendation for assault in the key generation. That's the only material change that we have. So other than that, versions 3, 4, and 5 they appear to be, their drafts 3, 4, and 5 appear to be technically identical in the practical case. You know, you're not actually going to pass in 0 bytes as your random seed or whatever. So it assuming a common sense implementation, nothing changes. Okay, so then we'll just get back to it. And the key thing that I discovered last time was the difference in the aggregate versus base function. So og scheme, we look at this from vendor. Oh, I got a call coming in that I'm going to decline because I'm busy working. All right. So there we go. This yeah, it needs to just there needs to be a core. This all just needs to be renamed to core, I think. Okay, and this is where I get confused, because look at this. This one is new og scheme. That's what it says in the Go Bindings README. But what's actually in the code from what we saw just a minute ago was, well, you know, I'll actually message on Discord. Let me see if I can grab that. Okay, where's the... All right. Let's see here. think that's what it was, right? Yeah, BLS signatures. Basic scheme. And this does make a difference because the augmented scheme is prefixed with the public key. The basic scheme simply makes sure that it's not possible to have identical messages. So, what I need to do then is essentially I need to copy. Should just be able to copy this. And then again, we could use the Ethereum version of this package, which is probably what we should do. But the rest of the stuff, I don't think it really makes a difference. All right. So then this one just becomes null. We can double check on that by, again, just looking here. SSWRO null. Yep, okay. Basic scheme. Let's go ahead and just change everywhere it says aug scheme to say basic scheme. Being kind of careful. All right, and then everywhere that it says ASM, I'm just going to replace it with S for scheme. G1 generator. Okay. So from that code, I guess we also have to find... Ah! I don't know what all that means. Oh no. Core aggregate. Alright, so we're actually going to have to copy probably the BLS out of here as well. No? Okay. Let's see what looks like core. Util, maybe? G1 generator. Hash. Derived child. Okay. Good to know that there's a derived child thing going on here. Oh, okay, the core functions are already in here. Okay, great. What was it saying? Private key? Okay, fine, we can do that. Right. Stutters. What can I do? Nice. I could call this package BLS schemes. How about that? No. Make it happy about the error string. Anything else? Alright, now interesting. I think this is implemented incorrectly, but let's see if we can find out what core sign. Show me the core sign. Okay, so this is the one that became the final. Was 5. And it went 2 years. Okay, cool. Show me the document. There we go. Core verify. Wait, it does take the public key. Then I'm confused. Is there a difference between basic and aug? Or core sign. That's I need core sign. Okay. Okay. Hash to point message. Signatures, point to signature, return signature. It's R value. Okay. So hash to point, where is that defined? Okay. So that's not going to have a secret value in it. All right. So the core sign is not going to have that. Oh. Okay. Alright, so that's... How's it going, everybody? Perpend, repend. Okay, that looks good. So we'll just take this over here, and then I think we will actually just get rid of these two lines, and then get rid of this, and then I think we're good to go. That actually makes that feel a lot simpler, doesn't it? Doesn't it? The answer is yes, it does. Oh, whoops. Oh, okay, so this is not actually following the standard. This function is incapable of following the standard. Not to say that the function shouldn't exist. The function can give the same result as the standard when used properly, but I don't know why. I mean, I guess there's circumstances where for speed you would want to use the public key you've already derived rather than rederiving the public key. That makes sense. All right, I'm on board. All right. Prepend PK bytes. There we go. All right. So there is the aug function implemented more correctly. And here we're just doing assign a single message, so we're all good, I guess? And then we don't need this sign with prepinned PK because we're not doing the signature that way. Okay. Oh, interesting. Hmm. Yeah, I kind of see what's going on here. What would be the best way? I don't know. We'll take those out for now. It'd be nice to make this more idiomatic Go. And I think given that the standard is finalized, the idiomatic Go would probably be that we have a new or create function where we tell it the scheme that we want to use, and then yeah, so say for example basic scheme, basic tag, augmented tag, and then that's of a particular type, new type. So we could do like type basic or domain separation tag is just byte. Well, I guess what would we do? So we'd have a basic tag and then an aug tag and then a pop tag. No, I think we'd have what I said before. And then this would be a domain separation tag. And then course sign MPL would have to take a domain separation tag. Okay. Yeah, like the code is designed to follow the spec, but the spec is designed to follow object-oriented rather than Go style. There are no material differences between draft 3, 4, and 5 final. It's just comments and a recommendation to use a salt. So now verify. Okay, verify of the message. This is for. Is this for the OG? Okay, we'll go ahead and update this as well. Let's see. Okay, so that looks good now. Core verify. Alright, message. Public key, hashed curve, from compressed. Engine point, pair, engine check. Alright. It looks like fast aggregate verify isn't mentioned here. Let's just take a look again at the difference between, basic scheme and message augmentation. I think the only difference is with aggregate verify, all messages must be distinct for basic. And aggregate there is no difference in aggregate for either of these, so they both use core aggregate. I think. Okay, cool. So this is good. This is good. So, okay. So it wasn't even the verify that's different. It's the aggregate verify. Okay, so that's even simpler for our purposes here today. And I don't know. So I think that core actually should be exposed. I think we should call it BLS core. Well, maybe not. That could be an internal package. So we could create an internal package called core. That makes sense. To me, that makes sense to me. We have an internal package called core. Yeah. I mean, we could also just re-implement the same things. I guess Go can decide whether or not it wants to inline it. I guess that's the... That's the truth. Okay, so no change there. Alright, so our sign function has been fixed. The verify function, I don't think actually needs much different. Oh. Okay. So this is non-optimal because we're doing more comparisons than we need to. But for small numbers of comparisons, it's probably the simplest way to do it. And I would imagine that under the hood, this would first check the size of the two things. And if the sizes are different, it just gets rejected. And yeah. Well, I mean, under the hood, this. It just would check the sizes first. Okay. All right. So I'm pretty sure I've implemented these correctly. I do want to make a change here though. So we have BLS schemes. Do I want to do this? All right. It's weird that it's called MPL rather than MPS. I don't know why it's not called. I mean, we could just get rid of the corn for all these. Boom! Oh, never mind. It's not a constant. What was this called? Assign, verify, aggregate, aggregate, verify. Aggregate, verify. I might need to check on this one. Because the core implementation here might be wrong. I have a suspicion that it is. Haha! It is! It does kind of make sense that you'd want to push that further down. So, okay, here's what we could do. here's how we could fix it and not lose the potential optimization. Yeah, this kind of points to them all being in the same package. But I kind of like the idea of the internal. Okay, you know what? We're just gonna leave this one be. Well, interesting. This one is byte sequences. The other one was not that way. I don't know if that's actually the way that we would want this. I think we would want this to be the public keys. But I could see why we would want them to be bytes for efficiency's sake. Okay. All right. There we go. Audio seems low, even when I'm speaking? Or are you just saying that the background music seems too low? Voice is low, music is okay. Let me go check. Is there anything weird going on with the voice? I mean, I personally am not speaking very loudly. Let's see. I mean, okay. So when I'm speaking right now, I'm peaking at negative 5 dB, which is what I expect. Checking properties, advanced audio settings. I think that the music is high. I don't think my voice is low. Because my voice seems to be very in the correct range. At least right now. I think that song might have just that piece of music may have just been particularly loud. And it wasn't being compressed away enough. So, let me know what you think about it now. Also, I just wasn't speaking very loudly. Okay, so append message. To messages. I mean, I can definitely compress the music a little more. Okay, now we're compressing the music a bit more. And then now we're turning the music gain down. So how does that sound with the music more compressed and with less gain compared to my voice? Because my voice is definitely in a good range, according to what I see here. Okay. Okay. Yeah, so I just slightly increased the compression, slightly decreased the gain on the music. Okay. That was a set of bytes. That was a message to a set of messages. PK messages. The byte. There's an array of bytes. That's an array of bytes. That's an array of bytes. Array of bytes to array of bytes. This is an array of bytes to an array of bytes. Let me look at the message for this one. I mean, that should make no difference. It's byte value and argument to append. I'm confused as to why this is Oh, am I doing this wrong? Okay. I'm having a brain fart. Appending to a slice. Oh, duh. Okay, that makes more sense now. Because I was doing a different type of thing here. We're appending to this byte array the message, the bytes of the message. We're appending to this messages slice the message. Right? There we go. Okay, let me go make sure I got that right in the other place where I had this. PK bytes. We got one signature. Okay, that's just straight on, no changes, no modifications, no nothing. So I'll accept that. Or will I? There we go. Okay. I feel good about that then. So this should still be able to pass any relevant tests. Alright, let's double check this now. Okay. What's the proper way to do this? It's like j in range I to the end of the range or something. There's a way to do this so that you actually only do the number of comparisons that are necessary. I'm going to ChatGPT it. Okay. Write a loop in Go comparing two slices of strings such that... No. A slice of strings such that each string is only this seems like a homework problem that it would be able to solve. And each string is only compared to, and each string pair is only compared once. Let's see what it gives us. Yeah, that's okay. String slice is I. That's right. Plus 1. Okay. There we go. That's what I wanted. Let's see if it works. Okay. Is that where we decided? I don't know if that's actually going to work. Yeah, I don't think that'll actually work, and the reason is because I plus 1 may be out of the range. Alright, if we've reached the end, then break, right? Ugh. Okay, messages, I plus 1. Okay, that seems to be right this time. Let's see. Is it ever possible for I to equal J? I don't think so. Okay, so I think that actually was correct. That this makes it not possible for I to equal J because when I is equal to 0, J starts in the 1 position. Well, okay, right. All right. Yeah. Okay. That's right. Okay, so never mind. GPT was right. Okay. This one makes the range bit feel silly. So I kind of just want to say for J, because we're already doing range of messages. I guess it's the same. So if this is at 0, then that's at 1. Okay. IB? I don't know what to call it. Okay, so that should give us our aggregate verify function. I would need to test this to make sure that it's correct. But let me just read over it again here. All right, so we're going to take the length of messages, which could be 0. And if it's 0, then this is never going to execute, and then we're going to skip down to there. But that's not allowed to be 0, and that should fail somewhere else along the line. Actually, let's verify that. Aggregate MPL. Engine add pair. Okay. What was engine then? New engine. So I do want to know, is there any stipulation about this being 0? Could we take a signature? No, we can't have 0 messages because we have to have public keys. So we'd have to have both the public keys. Yeah, and that should be an OR though. I'm almost positive that should be an OR. Okay, if the length of keys is not equal to the length of messages, or the length of keys is less than 1, which I think that would be better written as 0. Then return false. Okay. Add pair P and Q. Yeah. Yeah, I am pretty certain that was a typo because we wouldn't want it to be if they're not the same. It should just be if they're not the same period, because otherwise this is going to end up indexing into something that doesn't exist, right? Because either we're going to have too many messages, yeah. So it's if it's okay. So that, let's go back to the chwit here. Whoops. Let's see, did this actually test for the wrong length? It did not. Okay. Pub key. Alright, so this should be... Okay. Alright, well. Let's check a couple other of these things then. Do I see anything else like that? I just like to break this stuff down onto multiple lines as well. There's the G2 map. So is R, P, and E? Is that what I'm to understand? R, P, and E? Okay. Wait, where'd the Q come from then? Oh, the Q is in the middle? Wait, that doesn't make sense. Shouldn't that be a P? I mean, did I misread that? Did I? P. P. Q. Ah. Nope. It's called Q there. That should be P, not Q. I think. Let me go look at the spec here. Sine, cosine. Does it reference? Okay, it references it as Q. Okay, R equals secret key times Q. Let's see. So R hash to curve, hash to point. I guess it's the same thing. Q. SKR. What? They're not the same values at all. Mul scalar. Hash to point. Message with the tag. Okay, yes. R return signature. All right, SK. Scale and multiply. Okay, So this is not a regular multiplication. This is a curve multiplication. They're just using the same. They're overloading. Well, I mean, it's common mathematical notation for what they're doing. But, okay, that makes more sense now. So this is probably... It's not the same R. Okay, so maybe... Secret key and message. Q is hash to point. Point to signature. Okay, let's see what was point to signature. Point to octex E1. Okay, so that's the E1. Okay, points to octets. Okay, so it's hard to say what these truly represent here. Because hash to curve is hash to point is Q from the message type, which has got the salt. Hash to point. Yeah, they define it. They define it in a weird way. Yeah, I'm gonna call that PQ. I'll call it SKE. Are we doing a G1 or a G2 here? G2 map. Okay. So G2. It's a point G2. And what is R for? Okay, let's see if I can just get that signature going and test out what I've done here. I think I'm far enough along that I can do that at this point. So let's go check tender BLS. Sig bytes. Let's just try out the same thing here. All right, priv key. So what we would actually have would be BLS basic dot sign priv key message. Where's our message at? All right, let me double check on our BLS basic package, and that's in here. And sign takes a BLS private key and message bytes. Returns bytes. That looks right. Priv key is BLS gen key. So the thing that this doesn't have is it doesn't have the salt. Well, actually, I think it did have the salt underneath. So I think that this is actually doing a key gen based on the 05 spec. So I think that they are, and this doesn't surprise me because if you look at the code, the comments don't, they're not perfectly aligned, and that makes sense because over the years, a little bit gets changed here and there, and this comment is from 03 draft, this comment is from 04 draft. So I think that this, I don't think that this is draft for, again, the only difference technically is the keygen function has a salt that's applied to the seed, and that's being done. That's in Tenderdash and BLS signature, if I recall correctly here. Okay. BLS basic. All right, it's right here. Oh, whoops. I got the module wrong. I'll have to go back and fix that. That's fine. The function is called sign. Oh, I need to call new on this essentially. So well, also yeah. Well, we want this to be passed around. So yeah, we do need a new. All right, so let me go back to core. Internal. And then we need to create interface. Dun, dun. Okay. Yeah, type interface. Oh, it's just the name of the function. Okay. And then the return type. That makes sense, duh. Wait, how's... what? Oh. There we go. I don't know if I actually want that or just that. I'm not really clear on the semantics on that one. I need to look that up again. Okay, but that's about right. Alright, so now we can go back and hopefully finish up our demo. Oh, wait, I remember now. Yeah, I think that this kind of points to a particular type of use. Okay, so, alright, let's see if it works. First of all, let's just see if it works, if it runs at all. Which it seems like it should. Alright. That signature looks good to me. That's a good looking signature, folks. All right, let's just do a little quick comparison here. Ayo! And that kind of brings us to a good pause point for me to go have Din Din. It's a good one tonight. All right, cool. All right, so that worked out well. So what I actually want to do here is bring, let's see. Okay, internal. BLS basic. BLS basic. Oh, darn. Whatever. Okay. Is that basically what we're looking at? I don't think we needed that one. No, we didn't. Okay, good. So yeah, that's basically what we're looking at. 3 new files. Okay. Cool. All right. So what we have then is I would need to... So, okay, so what I'd like to do is create a fork of Tendermint, use these functions, and run the tests and have it pass all the same tests with the pure Go version as it passes with the relic version. And I think that where we're at, I think that should work. So that will be the next step then. The next step will be, we'll have to massage the format a little bit. So we'll have a little wrapper so that it fits perfectly in terms of has the same return signature for the error and creates the same... Oh. My phone? Something wrong with my phone? Oh, yeah, I did not get a call. Interesting. Huh. I don't have service. That's strange. Okay, well that would... Oh, all right. Anyway, so yeah, that's kind of where things are at. I'm out. This was a good one. Adios.